Yep. Hi.
Hi.
Hi there. Hi, Gustav. So, yep, as mentioned before, Daria said that it will be a workshop. I want to say that for now we will have like a talk about Mint language, and after that, after the session, after have like a workshop about the Mint language. So for now, I want to say a little bit about Gustav. Yep, because as Daria mentioned before, I have a little bit experience in languages, especially because I developed my own type checker. Yep, and because I like this like analyzation and compiler stuff, I heard about Mint, actually about his key parts, key concepts. Yep, and when I heard about it, I already pinged not Tanya, our program coordinator, that we need to have like a workshop or something like that about Mint, and especially from Gustav. Yep, and it was an awesome day when I heard that Gustav sent to us his proposal by himself. And it was the second awesome day. I thought that I had like a jackpot when I heard that Gustav will have two talks. First one, it will be like a talk about Mint, and the second one will be a workshop with like show a key concepts of Mint language and the best practices, like a cookbook. So I don't want to spend more time. I give words to you, Gustav, and let's show the best DSL for declarative building of our UI.
Thank you very much. Okay, then let's just start with the presentation. So I like to welcome everybody who's watching it live. Let's start with some introductions. My name is Gusztáv Szikszai, and I'm 33 years old, and I've been doing web development for over 20 years, 9 of which professionally, working as a software engineer. My background is a bit hectic. In middle school, I went to an art school to be a sculptor, but also during that time, I started programming, mostly because I was curious. And after a while, I did some contract work to have a little extra spending money. And after finishing the art school, I went to the Budapest University of Technology to be an industrial engineer. And if someone is not familiar with that term, it's basically a designer for physical products. And during this time, I did programming only because I wanted to learn and improve myself and maybe launch a product ultimately. I've dropped out of the university and I started working as a developer, and I'm working as a developer since. In the last few years, I had a number of open source projects, the most successful of which is Mint, followed by MUI, not the new one, but the old one. This will make some sense later. And some shards, which are packages for the Crystal programming language, which I will be talking about a little later on. So when I started to create this talk, I was asked what were the problems I wanted to solve with Mint. So I looked back and checked my old repositories in GitHub and Bitbucket and realized that I always wanted to create a UI library. And this whole thing started about 10 years ago, around the time when I decided that I will, do programming professionally. And at the time I was using Blender, a 3D modeling software for my studies. And its UI was so good that I wanted to recreate it using web technologies. And that was the first iteration of the UI library, Blender-like graphical user interface in the browser. Over the next 10 years, and after iteration and iteration, it just became a general purpose UI library. And in the next few slides, I'll share a snippet of a button component from each iteration, along with my experiences using the language used. So the first iteration was in JavaScript in back around 2010. So let's just go back in time and see what was available then. IE was the leading browser. JavaScript only had ECMAScript 3, so there were no classes or console object or the function bind function. And it was the time when jQuery and MooTools were used heavily, and CSS didn't even have Flexbox or Grid. And for example, there were differences in browser APIs. IE had the add listener function, and while Firefox had the add event listener function. And this version of the UI library was implemented using MooTools, which provided classes with extending classes and including mixins. And to just share the goals of this project, I find the README. And the goal of this project was to create a lightweight, extendable modular UI framework library, which uses the MooTools class architecture and has elements that are rarely seen in other libraries, but used in desktop applications or mobile device UIs. The next version was the rewrite of the JavaScript version, but in CoffeeScript in 2013. CoffeeScript is a language which has a lot of cool utilities, like list comprehensions, classes, string interpolation, and many more. And basically, it had the things that JavaScript has today, and it made working with it a little bit easier. And to have a quick note here, this version of the library used the old mutation events to check if a component was inserted into the DOM, and when it had, it initialized the associated component. So this was like a poor man's custom element. And this is from the repository for the goals of this library. And if we compare it with the JavaScript one that I had before, it focuses on having less polyfills or having less dependencies and make it extendable and such and like that. The next version was basically the rewrite of the CoffeeScript version using Opal, a Ruby 2 JavaScript compiler in 2016. At the time, I started with working Ruby professionally, and I liked the syntax and the DSLs that could be written in it, and thought it would be a good language to build the library on. And this version worked quite well, since we built a product with it, which has around 80,000 lines of Ruby code for the front end, which we still use today. And it has a few quirks. So it's still JavaScript underneath, so it has the same issues and errors, mostly because there is no types system. CSS are generated into a static file, while the dynamic properties are set as inline styles. And when I say dynamic properties, you can see that there are some blocks for some CSS values, which are dynamic, so those will be set as inline styles. Opal has a Ruby runtime, which has a pretty big overhead, since it creates an object for each DOM element and associates the two with each other. But it allowed us to use the same language on both the backend and the front end. and it's slow to compile since it's using sprockets, which is the Ruby version of like Webpack, which made development slow. And if I to gather the goals for this was to allow you to use Ruby on the front end, to be component based, and have like these reusable modules called behaviors, very much like hooks in React right now, and have the styling embedded in the code instead of a third party or a third file like external CSS file. And the last iteration of it was in 2017 when I was learning Elm, which was a very young language at the time, and it still is. And it didn't have any UI libraries, and as far as I can tell, it still doesn't have. And I saw an opportunity to rewrite my library in it, and I actually managed to finish it, and some people even used it. And this version came the closest to the ideal way for me of building web UIs. And not only that, but it had the developer experience, which is pretty good. So this has the declarative way of defining the UI. It's a type language, so if it compiles, it runs without many bugs. Values are immutable, and there is only one binary to do everything. Well, almost everything. The formatter and the language server is a separate package. However, I stopped working on this because the actual development of the language is very closed and not open-minded. And I say this because I ended up building a development environment, test runner, which I could test the components I built with, CSS and JS library, and even a package manager and a website for the packages. But it was not done according to the rules and the ideas of the core contributors to the language. So basically in the next version, which was 0.19, they deliberately made it impossible to use the things that I've written. And that's when I stopped using Elm. And the goals for this rewrite was to have a declarative way of defining a UI, made it type safe, error-free, and to have to give a language the first UI library that it could have. So understandable, after all of that, I was kind of fed up with the JavaScript and the most languages that compile to JavaScript. And in the next few slides, I try to tell you why. Around half of the languages that compile to JavaScript are mutable and imperative, like Ruby, Graphicscrypt, TypeScript, and a lot of others. And being mutable and imperative when building UIs is counterintuitive, since we need to keep the state of the UI in mind when we are developing. For example, to know when a button is disabled at a specific time. And at least if you do it declaratively, you can almost see the state of the UI from the code. And there are a lot of examples like this, which demonstrates this behavior. Since everything runs on JavaScript, its quirks can lead to a bunch of undefined behavior. And one of these quirks is how it treats equality. And I think everybody here is familiar with it and got burned more than once because of it. The only language which, in my opinion, did this right is Elm, where it does not fall back to the JavaScript behavior, but it has an internal comparison function. Another issue is that most languages don't have a static type system to begin with, or they take it too far. For example, JavaScript doesn't have it, and not having it causes a bunch of issues, while TypeScript takes it too far, at least for building UIs. For example, I took this snippet here from the source code of the Materia UI React library. And this is, as far as I can tell, is the definition of its button component, which is, for me, it's kind of hard to read and understand. And in comparison, when I used Elm, it spoiled me with its type system. It was simple enough to understand and write, but just powerful enough for creating UIs. To me, to go back to a typeless language is not a good experience. Okay, so here is the biggest pet peeve I have with the languages that we're currently writing UIs with. HTML and CSS, it's not part of the language. It's always separate in some way, and that's why we have a lot of frameworks out there which try to remedy this. In JavaScript, you need to use strings and tagged template literals if you want to create DOM elements in a declarative way, which has a runtime penalty, or you need to use a third-party library which converts the HTML syntax into function calls, or imperative code of calling the DOM APIs, at which point you may just use a better language since you need to precompile it anyways. The same thing is true for CSS. You either pay the penalty in runtime or compile time, and most CSS in JS libraries do their thing at runtime, while other languages do it at compile time. So most languages doesn't have some types, or more accurately, algebraic data types. And I learned about them when I was learning Elm. They are very good for describing the state of things, and in my opinion should be in every language out there. For example, JavaScript doesn't have them, but with TypeScript, you can do it, although in a very weird way. As seen in the snippet, having object with a shared field, which contain the name of each state, while the other fields can be anything. And I understand why it is this way, because it has to support JavaScript, because TypeScript is a superset of JavaScript. But in every other language that I encountered them, it is much simpler. And this is one of my favorite features, which is totally unnecessary in most cases. So if you used ReasonML or OCaml, then you know that when you reference something, the compiler tries to find the file containing that thing, and it will automatically load it. And just think back to all those times that you wrote the import-export statements in JavaScript or any other language, and not just that, but the time it took to understand how they work, what features did they have. And in Elm, this is even more verbose. I have files where the import statements doesn't fit into the screen, and I have to scroll down to get to the code. And this day and age, we are using machines which are much more powerful than ever, but in still most languages we need to define where the things are and how to load them, instead of the language figuring it out for itself. And to show you an example of the ReasonML, which I mentioned before, here we have two snippets: the main file, which references the duration module, and we have the duration file, which has the implementation of the duration module. So the compiler looks up the modules by name, and it doesn't matter where the file is, the compiler just finds it automatically. And in this case, as I said before, the main file finds the duration file. Another thing I've noticed that JavaScript, TypeScript, and some other languages have too much clutter. And by clutter, I mean lots of keywords, a bunch of return statements, the lack of the feature where you can assign a condition to a variable, A equals if X, then A else B. TypeScript is even worse because of the type signatures, which pollute the visual even more. And having done a lot of Crystal and Ruby development, I can say that their syntax is easy on the eye, and the most readable code I ever wrote is in these languages. Another thing which none of the languages support is assets. Usually this is always the framework's job to check if the asset you use, like images or SVGs, are there, and handles the minification of them and so on. So wouldn't it be awesome if the language would give you a way to embed data directly, or to convert an SVG into a component directly, or minify the assets that you have automatically? Type languages that compile to JavaScript need to interface with JavaScript, usually through a foreign function interface. And these interfaces can be complex. For example, in Elm, it's done through ports. In the Elm code, on the top, ports can be defined, which is essentially a type signature. And the port can be either outgoing, that produces what's called a command, or incoming, which is a subscription. And in the JavaScript code, which is below, which embeds the Elm application, we need to define the implementation of these ports, as seen in the example. Now, the types going through the ports is limited mostly to literal types like string and number, or objects that are containing these literal fields. I'm sure that you've seen memes like this before. To me, it is absurd that you need to download hundreds of megabytes of dependencies to create a website, simple website. I mean, I just want to have an interactive form where the user fills it out and gets some warnings, and most of the time, this needs a lot of dependencies. And I think it's partly because JavaScript doesn't have the types and the good standard library, and partly because how the community creates these packages of minimal functionality and left pad package, for example. And at the time of writing these slides, the default create React app scaffolded node modules folder is around 170 megabytes, which is crazy. And this brings me to the framework/library problem. I think we have this many framework/libraries is because the language is not good enough for what it is used for. For example, it doesn't have types, so people write X type checkers. It doesn't have a declarative way of building UIs, so people write X libraries for that. It doesn't have a build tool, so people wrote X libraries for that as well. And if you just check how many combinations these frameworks/libraries can have, then you have all of the other X libraries connecting the previous ones, and all of this just became because the language didn't have it built in. And it is more typical of JavaScript than anything else. You don't really find third-party type checkers for Haskell or Scala out there. And this is related to the previous slide, but the tooling is another thing that is all over the place for every language out there. And this is mainly because, it doesn't have these tools implemented itself. And this is why you see new languages coming with their own tools, like the formatter and language server, for example, Go or Rust. And this brings us to the next first questions part. So I will give the talk back to Artem.
So yeah, as I mentioned it in chat, we will have like interactive question answer session. So we will split our talk at 3 parts, and we'll have like 3 question answer sessions. So yeah, the first section is about reasoning. Why do you decided to build your own UI library? I mean, did you catch some problems with an existing infrastructure, or jQuery is not enough? Was not enough?
So I guess I just wanted to understand how they work. So maybe that was the motivation. And if I think back, probably it was because the ones that existed back then didn't have like this more complex inputs, like a color picker or a date picker, or the ones that Blender has. And probably that was the motivation.
Okay. About the languages. Yep. So you have shown problems of JavaScript like inequality, bad type system, but seems like languages as ReasonML/OCaml or PureScript already solve these problems. Why not ReasonML, PureScript, any another functional or ML extended languages?
Well, for ReasonML, it's based on OCaml, so you need to learn both to be productive. But mainly because they, as I said in the slide, where the HTML and CSS is not part of the language, and they have abstractions for these, but they are, using the language that is behind them, so it's not part of the language itself.
Mm-hmm. Okay, so let I see as the chat. Yep. One more question is related. It's like this question related to the previous. So, what could you say about ClojureScript? For example, ClojureScript has an like opposite version of how we should to develop our software. So we will not analyze our code ahead of time. We will like execute some parts of code directly in duration of development and try to test is this function work fine or not. What could you say? Could it solve the described problems?
Probably it could, but I just refer back to the previous question that it doesn't have the HTML and CSS inside of the ClojureScript language. And since a lot of people are familiar with those two, I think that having them in the language is critical.
Okay, it's like a funny question, but let's take it seriously. So let's imagine that we come back to 1996. Yep, and you are the main developer, main designer of language for scripting inside Netscape browser. So what key concepts would you include in this language? I mean, how did you design it?
Well, I am limited by the technology of the time, or I have the knowledge that I have right now?
You have a knowledge and problem, and you know the problems which will be in future.
So I guess then probably I would skip JavaScript altogether and focus on adding more things to the CSS and to the HTML specs to allow like more complex like these input fields and things like that to be implemented in the HTML specification. Because what we are doing with JavaScript and all of these languages is kind of trying to fix HTML and CSS so it would work for our use cases.
Did you block $sign to prevent jQuery existing?
Oh yeah, sure.
Okay, yep, seems like we finished this question answer session. Let's see the next part of the talk.
Okay. So at this point, you might ask this question yourself and wonder how Mint solve these problems. And I try to tell you in the next few slides. So Mint is a functional language with component composition, global entities, and immutable values. And you might wonder how can components, composition, and functional constructs can coexist in one language. And I try to answer that. Functions are used for the transformation of data mainly. Functions can be defined in like most entities and can be called in very different ways and can be composed like using them as arguments. And values by default are immutable. And this prevents a lot of bugs and issues later on. Mint has a value-based equality, which is for me more logical, and maybe some other people as well. So take JavaScript, for example. If you didn't know better, you would say that an array that contains an A character is the same as another array containing the A character. I mean, they look the same, right? Well, in JavaScript case, they are not equal because of the referential equality. But it would make more sense. It would make more sense to make them equal. And in Mint, they are the same, and this logic of equality is true for other values as well, like enums or records or objects. It kind of treats everything as value. Mint almost has the same type system as Elm. It's the Hindley-Milner type system. Mint has type inference also, but not everywhere. Usually the return types of functions properties can be omitted, but the function arguments must be typed. And this is because it helps the compiler a lot more. And if the compiler would try to figure out the argument types, then it would lead to some bugs later on. And since I mentioned this so much, in Mint you can write HTML everywhere, which is basically the virtual representation of a DOM element. And you can pass this value around, and in the end it gets rendered at some point. And CSS can be written only in components in the style tag. And not only it supports interpolation of values, but it supports if and case statements, nested selectors, media queries, keyframe definitions, which allow styling of an element or a component more naturally than any other language or framework can. And if you want to compare it to something, think about the style components package and combine it with Sass, and you get something that comes close. And in Mint supports some types or algebraic data types, and they are called enums. And they pretty much work like their counterpart in Elm. They can contain any number of options, and its options can contain any number of values. And in this example, it shows of the status of an HTTP request. And in the case statement, you can match on the possible options and return something that is relevant to that. And as I said in the other slide, import and export keywords are usually not needed in a language if it's constructed the right way. In Mint, you can just tell where the source files are, and the compiler will parse all of them, and what they contain is available everywhere in the other source files. And there are some questions probably that you might ask about this. Does it pollute the global namespace? Yes, it does, but the language is built this way, so it's okay. And if there will be any conflicted entities, then those entities should do the same thing. So it's not logical to have the same module doing different things. Another question might be that loading all of the library when there is only part of that you are using. And this is valid as well, but Mint has that code elimination built in. So only those parts that are compiled, only those parts are compiled which are used. And does it affect performance, you might wonder? And right now it does, but only for the initial parsing time, and which can be optimized further with caches or parallel parsing. And Mint doesn't use any cache for the AST, the abstract syntax tree. Everything is in memory. And having a cache would speed this up. The syntax of Mint was inspired by Ruby and Crystal, but I wanted to make it familiar so JavaScript developers wouldn't be deterred from using it. So keywords like the component or state or next are usually full words. There is like a property keyword instead of just being prop, which makes it easier to understand what is going on at a glance. The curly braces are there so the language looks friendly and accessible. And finally, Mint is an expression-based language, which only means that everything is an expression and everything should return one expression. And there are a few exceptions for this, but this makes it easy to follow the logic of the code. Mint offers built-in constructs to manipulate code at compile time, which are called directives. And one of these directives enables you to inline SVG into an application. On the top, you can see how the syntax looks like. And on the bottom, you can see how the same thing would look like if it were written by hand. So the bottom thing is what the compiler outputs. And this is very handy for embedding icons or illustrations. Another directive is the format directive, which allows you to get the source code of the block and its result in a tuple. And the tuple is a fixed set of values, where the values can have different type. And this directive is useful for displaying examples of components, for example, in documentation. On the left, you can see the syntax, and on the right, see how it looks after the compile time replacement. And as I mentioned before, languages that compile to JavaScript need a JavaScript interface, and means you can just inline JavaScript code using backticks, which means that the code will be injected as is at the position at compile time. This makes it easy to interface with Dev APIs and as well as external libraries that exist in the global scope. This is the actual code that is used for Json parsing, the example. Notice that the interpolation with the hashtag and braces, and this allows compiling Mint code into the inline JavaScript code. So you can go into an infinite loop of this if you would like. And if you used CoffeeScript before, this is probably looks familiar because CoffeeScript had the same JavaScript inlining functionality. Mint has a standard library which has the usual functions and modules. For example, functions to work with arrays, but also it provides a lot of utility which is needed for UI development. And some of these are the wrappers for commonly used web APIs, like the XHTML, HTTP request, mutation observer, WebSocket, local storage, clipboard API, which in other similar languages are provided as packages. And it has the providers, which are like, which I will describe maybe later on. But one of the providers is the shortcuts. And you can connect this provider to a component and say that what shortcuts are available for your application globally. And what actions to take when those shortcuts are pressed. And a language like this needs to be easy to use. And the best way to achieve that is to have a single binary file, which has everything the developer needs, much like a Swiss Army knife. And this is why Mint has all the things built to build UIs. So all the things built in, for example, a development server, a command to produce a production build, a formatter, a package manager, a test runner, documentation generator. And in the future, it will also provide a language server and a production server, which will, parse your Mint application and serve it in a port. And here I will talk a little bit about the comparison of a stack for a single page application written in JavaScript, Elm, and Svelte and Mint. And for example, to have type checking, Mint has it built in, JavaScript has TypeScript or Flow, Elm has it built in, and Svelte has TypeScript. And to have a virtual DOM library, Mint has this built in, JavaScript has loads of it. I just highlighted React or Preact, and Elm has it built in, and Svelte has a different approach, but it's built in. For styling things, in Mint, it's built in. In JavaScript, you need style components. In Elm, there is a package for it called MCSS, and Svelte has this out of the box as well. For routing, Mint has this built in. In JavaScript, there are a lot of packages available. I just highlighted React Router. In Elm, you have the Elm/URL package and the browser package. And Svelte has a different package for it, it's the Svelte routing. For data management, you have it built in Mint. JavaScript there a lot. Redux or Redux Saga comes to mind. Elm has this built in, and Svelte has this built in. For the development server, Mint has it. JavaScript has, for example, the Elm dev server, but a lot of others. Elm has it built in, and Svelte has the same as the JavaScript ones. Language server in Mint is in work in progress, but once it's done, it will be built in. JavaScript has TypeScript, and Elm has the Elm language server, like package thingy, and Svelte should have TypeScript as well. Documentation generator, Mint has built in. JavaScript has JSDoc, ESDoc, and a lot of others. You can generate Elm documentation JSON using the Elm binary, and I didn't find any for Svelte. Package manager is built in for Mint. JavaScript had Yarn and NPM, and probably a lot more. Elm has this built in, and Svelte is the same as JavaScript. Build tools, so producing a production build, Mint has it built in. You have for JavaScript, you have Webpack or Rollup or any other. Elm has this built in, and Svelte has the same as JavaScript again. For formatter, Mint has it built in. JavaScript has Prettier. Elm has Elm format, and Svelte can use whatever JavaScript is using. For testing, writing tests and running the tests, Mint has this built in. JavaScript has Jest and a lot of others. Elm has Elm test, and Svelte has something called the testing library something. And if we count this up, Mint doesn't have any. In JavaScript, you need at least 12. In Elm, you need at least 4, and in Svelte, you need at least 7. And one of the goals of Mint is to remove the burden of choice. And as you can see, it has everything built in except the language server, which is in development. And in comparison to other languages, so in a sense, you don't just get a language, but a framework as well, as part of the language itself. And it's time for the next set of questions.
Yeah, do you hear me actually? Yeah, seems like we do. So let's start from the questions from our chat. Bootstrap, material UI, etc.
Sorry, can you repeat that? I didn't catch that.
Yeah, sorry. So does Mint have any UI library like Bootstrap, Material UI, or Elm UI, or etc.?
There is no that I'm aware of, but I'm building my own, obviously, and it should be ready in a few months, and it should contain most of the things that people need.
Okay,
and I might be showing it in the workshop.
Oh, cool. So, does anybody propose to translate a popular solution like Material UI or Ant UI to Mint?
Not that I know. They are using this new trend of like the Tailwind CSS, then they can import a CSS file and then add classes like normally they would.
Cool. So it's a point to contribute, I think, for our audience. The next question: if Mint allows to inject JavaScript code snippets directly, it means that it does not provide soundness, isn't it?
No, but since you need to define what that inline JavaScript code returns, it's up to you to make that sound and type safe. But
yeah, so it seems like seems like we could return like an object as like equivalent for unknown in TypeScript in Mint. Yep, and after that have like actually Mint has something like type refinement, or in Kotlin it's called like smart casting, so that we could via if conditions inside the conditions define blocks in which our type has some concrete type. For example, we will have like union between number and string, and if we will have if conditions that our type of this variable is number, inside this condition we will have like type as a number, inference it as a number. Could we do it something like that in Mint?
No, not exactly, because in Mint there is no union types. You can do it with Enums, as I shown before. So that's the way of building like trees and the things that can have different values, just like in Elm.
Oh, cool. So the next question related to this styles approach. So it's really nice to have, as I think, to have this styles block inside component. But how could we solve the problem with common styles? Like, imagine that I have some, I don't know, container class or something like that for my divs. Yep. How could I use it inside my components? Could I do like some styles mixing or something like that inside Mint?
There is no actual language feature for that, but you can have external styles loaded into your application, which has like classes, and you can apply those classes into an element, or you can use inline styles as well, using a map, or just plain using a string.
Okay, so yeah, it seems like we will have like separated file with common styles, and we'll include it by amazing module system which you presented, like in line styles. Is it right?
Not exactly, but close.
Okay.
So, want me to explain it further?
Okay.
Okay, so basically, the styles you have in your component can use the component scope. So that's why there's no external styles, because most of the time you would want to have access to your scope in the component, like variables in your component. And I think that if you want to have like common styles, you should create a component with those styles and have like the content injected into those components. So the components are the basic building blocks that you can compose, and they should have the styles. But if you want to have different ones, you can use a link tag in the head of your build code, load the CSS, and add classes to your elements.
Cool. Sounds great. Yep, seems like we have no questions for this session. Let's continue.
Okay. So since we now have how to solve these problems, I can show you how it is implemented. And the idea of creating a language which is used to create user interfaces have been on my mind for a while. And I had a number of different designs for the language before I implemented Mint. And one of these was a language was named Rye, which I created in 2013. And as you can see, it was inspired by CoffeeScript from the indentation-based syntax, and Haml from the percentage before the tag names, which comes from, as I said before, Haml, which is a templating language in Ruby. And it was an imperative language which had like templates, an event system, and a way to style elements inline directly. And I've created a parser and compiler, and even to manage to create some example applications with it, like a to-do list or a chat application. But it didn't felt right, let's just say that. And also Mint didn't look like what it does today. And it changed a lot over the years. And this is what Mint looked like in the beginning. Back then, there was no state keyword to define states, but has an initial state, which was, it came from, it was like in React, you would do. And also, there was no try and sequence and parallel blocks. There was a do block, which had like this interesting syntax, which was inspired by Haskell. You know, the pipe, and then you do something. So yeah, it changed a lot over the years. And Mint build is using the Crystal programming language, which I might have briefly mentioned before. Crystal is a statically typed, compiled programming language with a Ruby-like syntax. And I'm saying that it's Ruby-like because the type system and the compiled nature of the language makes a huge difference. And why did I choose Crystal? I had a Ruby background and I liked the syntax, and it gave me a head start, so to speak. And I wanted something that compiles into a fast binary. And the other options at the time were Nim, Rust, or Go, which I didn't have any experience with. The architecture of the compiler is pretty standard, and all of it is built by hand. It starts with the parser, which doesn't have the usual tokenization phase that most compilers have. So it directly returns the EST. And because we didn't have the tokenization phase, implementing comments was a challenge in itself. And after we have the EST, there's a type checker that takes that and type checks the code and produces artifacts. These artifacts contain, for example, what resolved type of each node in the tree has, which is then used along with the AST by the compiler to generate the output JavaScript and CSS. The format they're also using the AST to format any source or part of the source code. It turns out that Crystal is a pretty good target for writing languages. For example, this is the parser for the interpolation syntax. Since in Crystal you have open modules, you can define methods for a class in different files, and each node has its corresponding parser in a separate file. which defines the method on the parser class for that specific node. So it can be used in other different parser methods. And the parser itself is a top-down recursive parser with exceptions when something goes wrong. The parsing stops at that point, and we can show the exception. The type checker is constructed in the same way, except having named functions for each of the nodes. There is an overloaded check function for them. And Crystal supports function overloading, which is a way to differentiate a function's body depending on the arguments. And in this case, it makes it possible to have a unified interface for type checking and type checking a node, which is a function call to the check function, which raises errors or resolves and returns the type for a given node. This example is the type checking for the root node. We go through each of its arguments and raise an error if it doesn't resolve to either string or number. And after that, in the scope of the arguments, we resolve the node's expression, which is then returned. The compiler works the same way as the type checker, using an overloaded function. This makes it possible to recursively compile a node tree. You can notice the added underscore for the function's name at the third line, and its missing counterpart in the fifth and eighth lines. The normal function calls call the underscore function if the given node is touched during the type checking. So basically, this is how that code elimination works. So if the node is not type checked at that time, then it won't be compiled in the end. At the end of the function, you can see the JS variable, which is basically an interface for a DSL implemented for generating JavaScript, which does optimizations such as remaining variables and removing white space. And I think the formatter is the most simple part of the whole language. It also uses an overloaded function with recursive calls. Here you can see that we call the format function recursively for the node of each of the index part, and also for the node on the left-hand side. And at the end, we return the formatted left-hand side and the formatted index inside the brackets. So I'm nearing the end of my talk, and at this point, I might have made you interested in Mint. But for full disclosure, I should talk about the current state of the language. So right now, what makes Mint a toy language, so to speak, is that it's small adoption. We are in the state where there are early adopters, but it didn't gain enough momentum to become something that people want to use yet. We are still pre 1.0, so the syntax and the API may change slightly. Also, what I gather is that people are not trying out Mint because it has no language server for it yet, although it's in progress. So if I get you interested, you can check out some real-world examples of Mint code. There is an implementation for the real-world project, simple to-do app, and actually the desktop application of the Accentro blockchain platform was written in Mint. All of these can be checked out and available on GitHub. Also, there are two products that I use Mint for. PixelDiv is a visual HTML builder, which I'm not developing anymore, and Base API, which is a service that provides simple APIs that new projects need, like authentication, email sending, or file and image upload. For both, I've used Mint for the front end and nothing else. Here are some links that you might find useful for the GitHub website, or if you want to try out in the browser, there is a sandbox available. And we have a lot of social channels in GitHub, Telegram, Discord, or Twitter. And I just want to say thank you for listening, and see you in the workshop in half an hour. And I think it's the last questions. I think you are muted.
Yeah, no, maybe.
Okay,
Do you hear me
I
now?
just didn't hear, sorry.
Yep. No, okay. So I think it will be our last question answer session for this talk. So if you have a question, you could ask it in our Telegram channel. So there are a lot of questions actually. So the first one about equals operator. So you shown before that you have like structural equality, but could we have an ability to check our records or our state by the link if we have, for example, a really huge records, I don't know, really huge with a lot of properties. So could we do like not comparison with structures, but with links like identity?
Yeah, by reference, right?
Yeah, exactly.
There's no built-in method of doing that, but you can always drop down to an inline JavaScript code and call the JavaScript equality operators.
Okay. The next question about the equals operator, could we override his behavior? For example, I have like record with users, yep, and my users will be equals not if his email and password will be equal, yep, but if I catch some user with the same email, seems like it will be the same user. Could I make like custom equality in Mint?
Not at this time. I have ideas how to implement such a thing. It depends where, if like there's a feature that a lot of people want to use, then we can have that, but not right now.
Okay. So the next question about mutability. So first of all, how do you implement it? Yep. And the second question about some optimizations under the hood, because if we spam our JavaScript with object, it will be a lot of work for our garbage collector. Do you have some optimizations for JavaScript to have like, I don't know, so for the developer we will have like immutable data structure, but under the hood we will have the same object which will mutate his property or something like that. So do we have some optimizations for to not spam our garbage collector?
No, there are no such optimizations. The immutable values basically are implemented in the standard library, at least in part. For example, when you create a new array method, the first thing I usually do in JavaScript is to create a slice it, so to create a new version of it, and then do the transformation on that version and return that. In the other part, Mint has a runtime, which is written in JavaScript, and it has a JavaScript symbol for checking the equality. And if you implement that symbol as a function, you can have a custom equality like function to compare two things that are relevant to that type. And also the runtime does the copying of records. So records in Mint are key value, a set of key value pairs for an object. And when you copy a record, it actually, the runtimes create a new object and copies the fields recursively in the same manner. So that's how you have immutability.
Did you think, actually, one more thing which came in my head about the optimizations under the hood which you have, yep. So how did you optimize? So as I mentioned it, you didn't have any and don't have any intermediate representation of your language. So you will compile your Mint language directly from abstract syntaxes tree. So how could you do this magic with optimizations, and especially with type checking you shown, but optimizations is interesting too. Yep. And did you think to use like Google Clojure compiler to I don't know, to have some optimizations inside JavaScript, not in Mint?
So actually, I built an interface for building like JavaScript objects. So there's a function that creates, for example, assignment, and it has this interface has two implementations. One implementation is for development, which has a bunch of white space and things like that. And there is an optimized implementation of this interface, which removes the white space and changes the names to like one character variable names and one character class names. So this is how most of the optimizations come from, by replacing variables and classes with like the minimum name.
So like uglification.
Removing white space and removing new lines when necessary. Mm-hmm. So when you build, you get an optimized version, but when you code, you can see the source, more or less.
Cool. So and
related to that, there is also that code elimination, which is usually done by like tree shaking in JavaScript, but in Mint you have the compiler, so you know that each of those entities that you have has been type checked, starting from the main component. If has it been type checked, so it was touched or not touched during the type checking. And if it's not touched during the type checking, you just omit that from the compiled output because it's not used.
Interesting. So the next question, maybe I lost something, but what renderer is inside? Do you use like compilation approach like in Svelte, or use some library framework for rendering inside?
Actually, we are now using Preact under the hood to render the UI or the elements. And before that, we used React. So the structure and the architecture of the compiler is built that way that we can just replace like a backend, which is React compatible. So and there is any new way faster implementation of a virtual DOM which is React compatible, Mint can use that as a backend.
Okay, and one more question related to it. So you've shown like FFI with JavaScript, so that we could use like JavaScript inside Mint. But could we use Mint component inside JavaScript like it could be in Elm? So because we have like Preact components, seems like we could use Mint components inside Preact application.
It is theoretically possible. I haven't had the need to do that, so I didn't really research how actually it can be done. But in theory, Mint could output something that you could import in your JavaScript or TypeScript application and use it there directly. Another way is to have like your source code compiled into an embeddable component, which you can use, which is implemented and you can use it, but it will come with its own runtime and their own version of Preact. So it will be a fully separate component that you can put inside your application somewhere if you would like.
And did you think about this approach like Svelte, so that we, instead of have this virtual DOM approach, we'll have like compilation in like performed manipulation with DOM?
Yes, I tried to explore that path, but the nature of the virtual DOM and its implementation offer something that the Svelte approach can't really. It's that in Mint you can just write HTML everywhere and they will be compiled into a virtual DOM node, basically. And then you can just pass this around as children or as a property or something like that. And Svelte is built in a way that you have your template and you know the state of that template and you know all of the DOM nodes that can exist on that template. So you cannot just take something from outside easily and put it inside your component render tree, because it doesn't work like that. And because of this, it's really hard to implement this kind of imperative code compilation part into Mint, because you have these HTML nodes everywhere, and then you can pass them around and do whatever, which is not compatible with that way.
Interesting. So it's one more point to contribute for our audience.
Well, yeah, if you can.
Yep.
So if you can create an imperative compiled version with React API, then it can be replaced in the backend. So.
Cool. And as I remember, after Svelte get a lot of hype, so there was a lot of project related to it. So I remember that it really, and for now we have like a solid project, as I remember. So it's like we have JSX inside our JavaScript, but this JSX will be compiled in DOM manipulations instructions instead of virtual DOM calls. So yeah,
there are
it's pretty interesting.
Some libraries that do that. Also, there is another approach that lit HTML and lit element does, which is parsing the HTML compile time and trying to return a template of it and then update the template only, instead of always recreating the virtual DOM tree. And maybe that can be even backend at some point.
Yep. About the compilation time, did you measure it, and did you compare it with existing solution? As I remember, Elm compiler has a really good compilation time. But if we take, for example, PureScript, it has the worst compilation time, as I remember.
The project that I kind of built, so I think the base API has like 15,000 lines of code, and the most part of the compilation time is attributed to the parsing, and it's around 5 or 7 seconds that it compiles, and 5 or 6 of it is the parsing. And that can be, as I mentioned in one of the slides, can be sped up. It can be sped up using a cache, or doing it, having all of the cores of your computer and doing it parallelly, which I experimented with because Crystal has now the multi-threading where you can play with it. So that's something that can be optimized further. But their compilation times right now are, I think, pretty good. Even when if you take the first time compilation will be like a few seconds, but after that every change that you make will be around sub 1 second.
Gusztáv, thank you for the talk. Artyom, thank you for the questions. It was really interesting, and we will continue at 12:30. And now we will have a JS quiz.
Cool.
Thank
see you later.
For having me, and see you later.
Yeah.
Yeah, see you later.